Hey everyone, another day, another DSA problem. So today we're going to look at 1840 maximum building height, which was today's daily problem. So this is listed as a LeetCode hard, but I think once you understand the intuition of it, it's fairly easy to understand. Yeah. Okay, so let's just skim through the problem statement. I will explain it again on my iPad. So you want to build n new buildings in a city, and these buildings are going to be built in a line numbered from 1 to n, and you have certain restrictions on the heights of how tall these buildings can be. Okay, so it says the height of each building has to be a non-negative integer. Basically, it's positive. The height of the first building has to be 0. Okay, so it starts from 0. The height difference between any two adjacent buildings cannot exceed 1. All right. So yeah, they mentioned that we are given an array of restrictions, which has an index value and a maximum height, which basically says at this site location or at this index, the building can have a maximum height of this, right? Okay, so considering all of this and all these restrictions, we have to return the maximum possible height of the tallest building, right? So we have all these restrictions given to us and all these rules, and we have empty land. So if we build buildings according to these rules, what will be the height of like the tallest building possible, right? So that's what the question is. Let's just jump over here and sort of recap, take a recap on that, right? Okay, so buildings are built in a line and they're labeled from 1 to n, right? And the restrictions on the heights of these new buildings, it says the building heights, building height has to be positive, right? Greater than or equal to 0. And the first building will always have a height of 0, right? And the height difference between two adjacent buildings cannot exceed 1. That's given. And city restrictions on the maximum height of buildings is also given. And the goal, as we saw earlier, we have to return the maximum possible height of the tallest building, right? Okay, let's look at an example. It's the same example that they gave. I'm just going to show it over here. So n is 5, meaning we have land of, let's say, like 5 sites, all right? So we can build 5 buildings in these, right? And the restrictions we're given here for the maximum height says this. So it says the second building can have a maximum height of, sorry, that's too long. It can have a maximum height of 1, okay? And then they say the fourth building can also have a maximum height of 1. So we go to the fourth site and let's build a building of size 1, right? And the remaining areas, we can just build buildings and make sure that they still follow the rules. So what were our rules? It was that the first building here will always be 0, so nothing can be built in the first site. That's 0 there. And adjacent buildings have to have a difference of 1, right? So if I start from here and I go to the second land piece over here, I can increase the height by 1, right? And I'm trying to maximize, so I'm going to build a building of height 2. And this also works out because this building's height is 1, so 2 minus 1, the difference is still 2 over here. And then I'm going to go to the fifth land, right? So I want to try to increase it. So from 1, again, if I add 1, it'll go to 2. So if I look at all the buildings that are built here, the maximum height itself is 2, and that's exactly what the answer is, as we can see here as well. Okay, so the answer is 2. That's that. And they've given another example over here where there are no restrictions and we have n buildings. So this is basically like saying, okay, they've told us that the first building will always be 0. So if I want to increase from here, I know that I can only increase in increments of 1, right? So I'll go to the second land plot over here. I'll increase it by 1, increase it by 1. So if I do this, the maximum height that it can reach will be 5, which is actually n minus 1 because we start from 0. That's pretty basic. Okay, so the third example is kind of interesting. I will explain that, but I'll explain it do a run through it after we actually go through the steps and see how it should be solved, and then I think that's better. Okay, so these are the steps to solve the problem. I am going to go directly to this. I think this is one of those problems that you actually have to have solved it before to know how to do it. So let's go through this. Okay, so we'll I'll probably take the same example over here. We have certain restrictions, which is given to us as 5, 3, 2, 5, 7, 4, and then 10, comma 3, and then we have 10 buildings. Okay, so one thing we want to do is we're going to use this restrictions. We are only concerned about what information has been given to us in restrictions, right? Using that information, we're going to figure out everything else. So we're going to operate on this restrictions array. So the first thing you want to do is you want to add that building 1 because you know that it's always 0 and we're going to have to utilize that value going forward. So I will add that to this. I'll add that over here. So building 1 will have a height of 0, right? Yeah. So we're going to add that. And then we want to go ahead and sort this because we will be going in a sorted order from left to right. So let's go ahead and sort this. So it's going to be, it's going to be 1, comma 0. Then we have 2, comma 5, 5, comma 3, 7, comma 4, and then we have 10, comma 3. Okay, we're going to sort that. And then we also want to check, so the height of the last building, right? So we saw in that example that if we start from 0, let's say we had no restrictions and we had like, let's say 5 sites, okay? So this is 1, 2, 3, 4, 5, first building starting from 1, and this was of 0. So if we had no restrictions, the maximum height that it can reach is it can go to 1 here, 2 here, 3 here, and then it can go to 4. So the maximum height of the last building that it can possibly have will always be equal to n minus 1, okay? So in this case, we have n is equal to 10, and they have given a maximum height possible for the last building. If that wasn't given, then we would have gone and added that to our restrictions array, and we would have added it as like nth building, and the maximum height for that is n minus 1. In this case, fortunately, they've given it, or else this is a point you should remember. Okay. And then I told you that we're sequentially going to go and traverse these restrictions, right? So the first thing we'll do is we're going to go from left to right. And then we're going to update the height based on these rules. So let's just take an example over here. We're given 2, 5, 5, 20. Let's just forget 0 over here. Let's just consider these two as an example. So the second building has a height of 5. And the fifth building has a height of 20. Now, we want to see, is this even possible? So what our rule says is that when we're going from building to building, we can only do an increment of 1, right? So if I did start from 5 over here, and in my next position, let's say I did an increment of 1, so it would have gone to 6, and in my next jump, I would have done another increment of 1, it would have gone to 7, and my next jump would have gone to 8. But I see that 5 is at 20, and 20 is the maximum they've given. But following my rules, from the second building, if I reach by increments of 1, I can only reach a maximum height of 8. So that's where we're going to check from building to building, right? We're going to check its previous building. Since we're passing from the left, we'll check its previous building and see, hey, so the building right here, I've actually assigned it to its maximum height, but is the maximum height even possible? So how do I get if it's possible? I take the previous building's height. I take the number of jumps that it can possibly make, the increments, and how do I get those increments? So I get that by the difference in the distance between them, right? So that would be 5 minus 2. So a maximum of height 5, it can jump to 6 to 7 to 8, right? And 8 would have been the maximum that can possibly reach. So I'm going to go ahead and update this, and I'm going to remove this extra height, and I'm just going to say, no, that's not possible. So this is going to, it's going to become a height of 8, right? So we'll be updating the height of the fifth building. And that is given through this formula over here. So the current height of that will get updated to the minimum of whatever it was. It could have been smaller. And the previous height plus that distance. So we want it to be the minimum of those, right? Because whatever is possible. And maximum height is obviously the max that they have given, but we can't also like, let's say the building before it was like, let's say it was 6 and this building was 3, right? And then we had like 6 could have turned to 7, it could have turned to 8, then it would have turned to 9, which is not possible because the maximum height here is 3. That's why we are checking the minimum of either what it already is plus whatever increments could have happened to reach it. And we always make positive increments because the goal here is to actually maximize the height, right? So there's no shortening it anywhere. Okay, so this was our left to right pass. Now we also want to do the same thing from right to left because, as they've said, no two adjacent buildings can have a difference of height greater than 1. So adjacent buildings comes from both sides. And we want to make sure that that rule holds good for both sides. Okay, so we'll do the same thing here. So my fifth building has a height of 10. And then I see that my second building has a height of 100. That's not even possible, right? So 10 would have gone to 11, it would have gone to 12, it would have gone to 13 at max. But here I have 100. So I'm going to go ahead and update that. And I'm going to remove this and say, hey, no, the maximum height you can actually have is 13. Okay, it's the same exact thing, but we do it in the reverse fashion. So the current height will actually be the minimum of the current height plus the next height and whatever distance it could have increased from there. Yeah, the same thing. We need it from both passes to hold good for this condition. Okay, and once we get all of this, we haven't calculated the heights of what the buildings in the middle can be, right? And this is where we're going to do that. All right. So we want to find the tallest building that can be possible between these two buildings, right? Because this can increase, this can increase. So at some point, they're going to both increase and intersect. And then from each side, they can decrease back. So the condition will still hold good. So let's look at this. Building 2, let's consider this as like x1. The coordinate is 2. And the height of it is 1, and then we have a building here. It's x2 is at a position 8, index 8, right? And its height is equal to 3. Okay. So we see that there is a distance here. The distance is actually given by 8 minus 2, which is equal to 8 minus 2 is 6. Okay, I'll put that as 6. So if I start from 2 and I can go towards increments of 6, then I can actually go from 2 to 8, right? So I would have gone in an upward direction like this, okay? 2 plus 6 is equal to 8, something like that. And I start from 3 over here, a height of 3, and 3 can also increase, right? So 3 would have gone from 3 plus 6 increments, so it would have gone to 9, something like this. Okay, and then we look at wherever that middle intersection is because let's look at that over here. So right here, it's 5, right? So if I had started from the building with height 1, I would have increased it to 2. I would have increased it to 3. Okay, and then I would have increased it to 4. I could have increased it, sorry, I have drawn this wrong. I could have increased it to 5. And from here, I would have increased this to 4. I think I made a mistake somewhere here, but yeah, and probably this would have remained 5 or 4 again. But that would have been the optimal answer. So the maximum height that could have been reached would have been 5. If I had gone to 6, I wouldn't have gone back to reach both of these positions. So the middle height here is the maximum height that can be reached. I know I made that a little messy, but yeah, just take my word for it. So how do we get that maximum height? So there's actually a formula, and this comes from the fact that from the left side, we can go a maximum of distance. From the right side, we can go a maximum of distance, but together they can only reach 1 point, right? So that I've written it here. It can be created by climbing from the left and climbing from the right. And the total distance that's available between these two is distance itself. So whatever increment from left and whatever increment from right, we can at max add distance height increments, right? So we'll take height 1 and then height 2, and then the distance that could have been added, and we will divide that by 2. So this is the formula. Might seem a little confusing, but that's what it is. So yeah, that's the formula. And once we use that formula, we will be able to get the maximum height there. So what we're going to go through all these buildings, and we are going to check. Yeah, so our answer is going to be the maximum of answer and whatever this peak height is, right? Over all the restrictions after modifying them. So we are going to start again from like 0 to like n-1, and then we will check it with the next restriction. So we'll be able to find this value. Like using those values, we'll be able to find the peak between these, and we'll take that as like we'll try to maximize that and take that as our answer. Okay, so I hope that part was clear. Let's just check the complexity, right? So the complexity is m log m here because I'm assuming m is the size of our restrictions after it's been modified and I've added like these extra 2 values. So m log m because I am sorting. And then the rest iterations, left to right, right to left, and then the last final pass, that's just 3m. And then space complexity is OFM. That's just basically restrictions because we're using that. But yeah, okay. I hope you guys understand it. So somebody had requested me to type out the code. I know this is already a long video, but if that helps, then let me go ahead and just type it out. Okay. So the first thing we discussed was, let's just look at these steps over here. Right. Okay. The first thing was you want to add building 1. So restrictions is a long name. So let's just reassign it to be called R. Okay. So now I want to go ahead and append building 1 was a height of 0, right? So after that, I want to go ahead and sort this. So let's sort it. And I mentioned, right, we want to check if the last building is there or not. So we know that if it's sorted, the last value should be the last building. So let's check if the coordinate of this last building is equal to n. If it's not equal to n, as in the last building does not have a maximum height, then I want to go ahead and assign that maximum height to the last building, right? So that is going to be append, so last building, which would be the nth building because we're starting from 1, and the height will be n-1 because heights are starting from 0, right? We'll add that. Okay, so what was our next step here was add that. Okay, we'll do our left to right pass. Okay, so let's go from left to right. Just a minute, I just want to turn my phone off. Okay, so let's go from left to right. All right, before that, I want to kind of keep track of M, which is going to be length of restrictions, which is R now. So, all right, so let me start from the first building so that I can compare the left side building to it. So for I in range 1 to m. So what do I want to do? I want the distance, and I want to update the value, the possible value that this could have, right? So let's calculate distance. So distance will be equal to the difference between these two. And I know that our coordinate values, like our position, land positions, are stored in like the first value of restriction. So distance is going to be equal to r of I comma 0 minus r of I minus 1 comma 0. All right. And then I want to go ahead and update my my actual value here. So the height will actually be equal to the minimum of whatever it already is, and what it possibly can be. So then it will be r of I minus 1 and whatever that height was, plus the distance that I could have used to get there. Okay, so now we're gonna do our right to left pass, which is the same thing, but from the right side, right? So I want to start from the last the value before the last one. So for I and range, n minus 2, because n minus 1 is the last value, we don't want to take that. Minus 1, comma minus 1. All right, so distance here is going to be equal to r of I plus 1, because the next building, right? That site value minus r of I comma 0. Okay, and I want to go ahead and update the height of wherever I am to be the minimum of itself, 1, and the building which is after it, which could have grown to come to it, like what was the maximum there, right? So that's going to be r of I plus 1, and the height of that plus this distance. Okay. By the end of this, we have actually like marked the possible actual maximum heights of these buildings. Now we want to go ahead and actually check their highest point, the peak point, right? So we'll store our answer as 0 for now because we're trying to maximize it. And let's go for I in range n minus 1, okay? Because I still want to have a next building to compare with so we can find the peak between them. So yeah, I was, as we took earlier, x1 comma height 1 will be the first building, then we'll take the next building. This is just to make it a little easier to understand, right? So this will be r of I comma 0, which is its index position. And then we have r of I comma 1, which is its height. And then the next building's coordinate and height would be r of I plus 1 coordinate, and then r of I plus 1, and then 1, which is its height. So the distance between them is x2 minus x1. And what did we say the peak was? We had a formula, right? So we can take that as peak, maybe. So peak was height 1 plus height 2 plus distance divided by 2. So we will have h1 plus h2 plus distance divided by 2. And I want to maximize the answer, right? So the maximum answer will obviously be one of these peaks. So answer is equal to maximum of answer itself and whatever peak we got. So by the end of this, if I haven't made any mistakes, returning answer should actually give me this maximum peak value. Let's just check. I have made some mistake. Okay. Invalid syntax for I. Okay, I forgot to write in range. Okay, great. Yeah, there we go. That's a LeetCode hard problem, which has been solved. And as you can see, it is not that hard. So this is a really nice problem. I think there will be a lot of repetitions of this kind of pattern. But yeah, I hope you guys understood this. And yeah, just happy coding, everyone.